A look at the idea of summing and subtracting rational expressions. Again, what's something that's rational? What does that mean? Something's rational.
Integer or term that you're repeating decimal.
Integer.
It's something that can be written as a fraction.
Yeah, that's the way I like to do it. So integer, turning decimal, or repeating decimal, but really it can be written as a fraction. All those things can always be written as a fraction. So when you hear rational, think fraction. That's what this is here. So an expression means it has variables and probably numbers. So we're taking expressions with variables and numbers in them and fractional portions and adding and subtracting them. So we're literally just adding and subtracting fractions. But we're taking a look, instead of that, we're looking at variables. So here's our simple enough rule, which you know this, you've just never probably seen it written this way, but you know that. When you have the same denominator, what do you do to the numerators? Add or subtract, depending on what it is. Okay, so mathematically or numerically, a simple example. Let's say 1/4 plus 3/16. How would I sum these two together? Luca?
Change 1/4 to 4/16 and make it 7/16.
Okay. Now, this is what I find interesting. Most people can do this very simply with numbers, right? Because you think, what factor is missing that I have to multiply by to give me the same denominator? And it's clear that 4 times 4 is 16, so you multiply by 4 and 4. Right? That's how we've learned this, and we've learned this in middle school. It's the same approach with variables, but sometimes people get a little bit confused with it. It's the same approach though. So again, we looked at this and we said, what factor is missing from here that is here? Well, how do I know that this 4 times 4 gives me 16? Because 16 is really 4 times 4. So the easy way to look at a problem like this is to think of the prime factorization of something. It's always the easiest way. So here in this case, we'll start with 4 times 4. We can go further. This is really 2 times 2 times 2 times 2. Well, that's what this is. 2 times 2 times 2 times 2. So in the end, these 4 factors are here. Well, these 4 factors are really here. So we can sum them together. So if the denominators are the same, meaning if they have all the same factors, the key here is factors. I keep saying that on purpose. If they have all the same factors, we can then sum them together. So let's look at an example algebraically. Okay, algebraically. I think I'm going to give you some steps. Why don't we quickly just read through them? Right, read the first step for us. First step, Rob?
Oh, factor all denominators completely.
So, like we had a moment ago, we had 16 as a denominator and 4 as another. Had we started by factoring that into 2 times 2 on the left, and 2 times 2 times 2 times 2 on the right, we would have recognized that 2 2's were missing and the 4 was missing. So, now, number 2 is going to tell us?
On this common denominator of each fraction, multiply numerator and denominator of each term by what is missing in the denominator, leave the denominator in factor form.
Okay, so think about what factor is missing from each of the denominators. So if I have like x plus 2 here, and on this side I have x times the quantity x plus 2, clearly x is missing in this one. It's over in both. It's in this side. There's x plus 2, but here's just x plus 2. So multiply by x over x, because that's what's missing. Alright? You're going to leave the denominators alone. Why might you not multiply out the denominators? The factors in the denominator. Once you get x times x plus 2, why might you leave your answer like that? Why might you not write it as x squared plus 2x? You can look ahead of the steps, or you can take a guess.
So if you don't have an exponent in the denominator?
No, you don't have an exponent denominator.
You want to simplify?
You might want to simplify it. So if a numerator gives you an answer that can be factored, and one of those factors can cancel with one of the factors in the denominator, you can simplify the final answer. That is step 4. Or guess that or so, whichever. So make sure to add or subtract the numerators in that process. Let's look at an example. Okay, so take a look at this one. Factor completely. So on the left-hand side, that denominator looks like it's something you probably don't want to factor. So maybe start with the right fraction. If you have trouble factoring, what do you always start with in an expression? You always look for a what? It's a 3-letter acronym. if you're trying to factor something out, GCF. So look in the right fraction, look for a GCF in that bottom fraction. What can you take out? 3x. So if there's a 3x in the right fraction, we should probably see if there's a 3x in the left fraction. How can I write the left fraction using 3x or involving 3x?
3x squared. About 3x.
Yeah, right, this is 3x, there's 3x on the left, because you have 3x on the right one. So let me show you what I'm saying. So Mike is exactly right. We start with this 3x in the denominator, leaving behind the x plus 1. Well, over here now, it didn't seem like we want to factor 9x squared, but because we see a 3x over here, let's try and factor this into something that looks like that. So Luke is right. Right, it has 3x times 3x. And I know that's 3x squared. I'm going to write it like this just for a moment, just so we can physically see. Okay? So, we then look at our fractions. Well, a left fraction is missing what in its denominator that's in the other denominator?
X plus 1.
X plus 1. Okay, so this is missing x plus 1. So like I would do with numerical values, I multiply by like 5 over 5, I multiply by x plus 1 over x plus 1. Now the left fraction has everything the right fraction has, but the right fraction is missing something. What's the right fraction missing in its denominator?
Another 3x.
Another 3x. Okay, I don't have to put the times symbol, you should know by now that it's there, but I'll put it so it is. Now the denominators are the same, so we can easily sum them together. So carry down the denominator. I'll write it with the squared just because it makes sense at this point. That's our denominator. How do I figure out what the result of the numerator is? How do I figure out the result of the numerator? Simple, right? Algebra. What do we do? Or arithmetic at this point.
Distribute the second fraction.
Yeah. So we get 7x plus 7 over here. Good. And on the right-hand side we get? 3x squared. Okay? So it turns out that we're going to have a quadratic in the numerator. What should we do to check? Or what should we check for? Yeah, we should check to see if the numerator has roots or if it factors, really, yeah. Now, what do you think the common mistake would be at this point? Point out the common mistake.
To factor out the quadratic.
No, you can try and factor out the quadratic. That would actually work. If you can. You can try it. What's the common mistake, though?
Cancel 3x squared.
Yeah, it's very tempting to want to do this, isn't it? I know you can clearly see it's not the same, but we should know, even if it was the same, even if this parentheses wasn't here, because this is clearly really 9x squared, okay? Even if this parentheses wasn't here, it still can't cancel, because this isn't a factor, it's an addend. These are terms. They're all addends. You can't cancel with factors. So let's try and factor the numerator. What way should I check to factor here? What would be the only way to factor this? Yeah, AC method. So let's try it and see. So AC turns out to be 21. B is 7. Are there any numbers that multiply to give you 21 and add up to 7? What are the only factors of 21 really? Besides 21. 7, 3, and those don't add up to 7. So is this factorable? No. Okay? Easy enough. So we don't have to go any further. So this is our final answer. Okay, again, I mean, if you want to write it like this, by the way, that would become 9x squared, really, right? This is really 9x squared, distributing to both of these. Okay, that's fine. You could write your final answer like that, but what I was saying earlier was not to multiply out the denominator until you check if the numerator can be factored. But both answers are indeed correct. Why might I be going over both answers right now? What kind of a problem would it... Yeah, or any sort of... multiple choice, standardized question. For that kind of test, you have to think about the fact that your answer might not be the answer given. So you have to manipulate it. But both answers are correct. I could have written with the 9x squared, 3 quantity 3x squared, or bring the whole denominator and multiply it out.
If it was factorable, would you like leave the numerator as a factored version?
If it was factorable, you would factor the numerator, try and cancel, hoping that one would factor would have been x plus 1. If it didn't cancel, it doesn't matter, same as this. You could leave the numerator factored or you could write it out. It really doesn't matter unless it's multiple choice. Okay, then you have to maneuver that correctly. Example? Try this one on your own. Okay, if you want to work with the person next to you, that's fine. Try this one, see what you do. Again, same steps. If you forget what to do, look at your steps, they're listed there. Okay, look at your denominators to start. You should be at least through step 1. Come on. Check the factor at the bottom of the weighted fraction. Goes for the left fraction, I have to remember. Charles, what area?
No. I'm going to put up some of the beginning steps. A lot of you seem to have gotten part of it so far. It's possible. I was looking at your factoring though. Now recognize that you need to FOIL or double distribute the numerator up here. So making sure to do x minus 3x plus 2. And making sure to distribute this 2 to the whole thing in the numerator over there. And look what I'm doing already, to remind myself What kind of a problem was this? What kind? Not addition, but
Oh, subtraction.
subtraction. So look what I do on purpose. I purposely write this with a minus, but a big bracket, to remind myself that whatever I get in the numerator, I'm subtracting the whole thing. These are the careless mistakes I see on a lot of your tests. Careless mistakes don't work on standardized tests. You know that. Got to be perfect with it. So think about this. When you're distributing it out, you're going to have a negative 4x minus 2. So you're going to have to negate all those. So these are going to become positives. Positive and positive. Okay? At this point, what should we do? What should we do? What should we do?
Try to factor x for 3x minus 1.
Try to factor the numerator, which it definitely factors, right? What does factor into? The numerator. What does the numerator factor into?
X plus 4 times the quantity x minus 1.
X plus 4 times the quantity x minus 1. Very good. And we can all, I hope, see why it's convenient. What happens?
You can cancel out x minus 1.
Here those drop, giving us the final answer of x plus 4 over 2 times the quantity x minus 3. Again, this denominator could be written as 2x minus 6, right? Distributing the 2. You can write it that way also. Make sense, the idea? I think this lesson is really pretty simple if you just think about what you would do if numbers were involved. Okay, and if you practice this, it's really just a skill. The next 3 sections are going to build on this. And then the next chapter altogether, which is going to be our next test of the year, the test 12 stuff, is going to be about what are called rational functions. So these skills of rational expressions are used with rational functions. Alright? So if you want to start, you can start the homework on this. I'm going to give you a little bit of time here.